Okay, ladies and gentlemen, here is a short video on some review of algebra for calculus students. We're going to need this material next week. You're starting to see it more and more now, and I've had people come in for office hours, with these kind of questions. So what I like to do here is go over something here with you guys, like I said I would, and how to do some algebra here. Now, the first thing that's been popping up is this idea of simplifying a radical. Now, what you're really looking at is a rational exponential. So this is called having rational, which is a fraction, exponents. And you have a fraction here for your exponents. It's really a radical, though. Now, if you just use the definition here of what this is, right? This is going to be the cube root of x to the 7th, because you're using the definition of a rational exponent, rational exponentials. And that's x to the m over n power is the nth root of x to the m. So I'm looking at that first one. I'm only going to do the odds. I'm not going to do the evens. I'm going to leave the evens for you. But for the odds, ladies and gentlemen, you know you have a radical that can be simplified if the power here, this 7 power that we're looking at, if it's bigger than the index. So that 7 is bigger than 3, that means we can simplify the radical. And this is why I say, and I called this simplifying radicals. Okay, this is why we did that. Now, I'm going to show you a nice, quick, and easy way to do this. This is x to the 7/3. This is an improper fraction. I want you to write this improper fraction as a mixed number. You see, if you take the 3 and the 7 and you divide, you get 2 as a quotient. 2 times 3 is 6. I get 1 as a remainder. This is the divisor. This is doing the dividing. We call it the dividend. So we can write, I'm going to change colors here. 7/3 can be written as a mixed number. That's 2 and 1/3, because remember, your mixed number is the quotient, the remainder over that divisor. The dividend, also known. Now, a mixed number is written as a sum here. So we can write this as q plus rd. And what this is really saying is that 7/3, that fraction, is 2 plus 1/3. Okay, so it's 2 plus 1/3. So you're going to do a little bit of arithmetic here. So what happens now is we look at this and we say, this is x to the 7/3 power, which is the same as x to the 2 and 1/3, which is really x to the 2 plus 1/3. So we're focusing just on this power here. 7/3 is 2 1/3, which is 2 plus 1/3. Okay, so you converted the improper fraction to a mixed number. Now, here's what I want to say as well. You're going to use some more algebra. Your use of this property, I'll say x to the n times x to the m. It's a different n and m. Is x to the sum. So we know this from beginning algebra, but if we read it backwards now, this means x to the sum of powers is x to the n times x to the mth power. That's an m now. Now, this is what we're going to use. Okay, we're going to use this here because this is our sum right up here. Okay, and so what we're showing is that x to the 7/3 can be written as x to the 2nd power times x to the 1/3 power. We're using this property from beginning algebra. And so at this point now, we want to remember what this is by definition, x to the 1/3 power. We can write this as a radical, but that's a cube root. This is the cube root of x to the first power, which is just really the cube root of x, because again, from algebra, any exponential with the first power is that, or I should say any base to the first power is the base. So here's a nice, really quick and easy way to describe x to the 7/3 being x squared, the cube root of x. Notice that your power here, 1, is smaller than the index, so that's a simplified radical. And ladies and gentlemen, this is what I'm looking for you guys to do. So if you notice in the calculus course that we're working on, if you notice that some of these answers that you get, you look in back of the book, you might have done the power rule and you have x to the 7/3. And in the back of the book, you see x squared, the cube root of x, and you wonder, what did they do? What happened? Well, they simplified the radical because x to the 7/3 is really, by definition, this cube root of x to the 7th, but it's not simplified. So ladies and gentlemen, this is the procedure that I recommend you guys learn how to do. It's very simple. You can even do this in your head. You can even convert a improper fraction to a mixed number in your head very quickly and easily, and this is why I go with this approach. But I'm only going to work on the odd numbered questions. I'm going to leave the evens for you, and I might put an answer sheet up somewhere for you guys on the evens, and you can take a look at that. And ladies and gentlemen, I'm just going to work on the odds now. Okay, so here we go. We're going to do the next one, number 3. So we're going to focus on the power, right? So the power here is 4/3. So I'm going to take this 3 and divide by 4. I'm sorry, take 3, goes into 4 once. 1 times 3 is 3. Subtract, I got a remainder. So quotient, remainder, divisor. So here's the 4/3. This is what we focused on. So now 4/3, maybe we put it over here, is 1 and 1/3 as a mixed number. Okay? Which is 1 plus 1/3, because that's what a mixed number is. It's a whole portion plus a fractional portion. And what that means now is x to the 4/3 is x to the 1 plus 1/3. 4/3 power here, we know that's the sum. What that now means is x to the first power times x to the 1/3 power, or simply x times the cube root of x. And there you go, ladies and gentlemen. You simplified the radical. 8/3. 3 goes into 8. So we're going to look at this power here. 3 goes into 8 twice. 2 times 3 is 6. Subtract, remainder 2. So 8/3 is written as, let's take a look. Okay, here we go. Sorry about that. We're converting to a mixed number. Quotient. Two plus 2/3. Okay, because this is really what a mixed number is, a whole portion plus a fractional portion. So that now means x to the 8/3 becomes x to the 2 plus 2/3, which will be x squared times x to the 2/3, which is x squared times now the cube root of x squared. And there you go. Now, in case you guys forgot, I'm going to put this down here again. X to the n over m, and I think we wrote it the other way, m over n. The nth root of x to the nth power, and x to the 1 over n is the nth root of, you can say x to the 1, but anything to the first power is itself. So in case you forgot about this, these are the definitions of our rational exponents. But you simplified the radical, and they are radicals. So there we go. 8/5. 5 goes into 8 once. 1 times 5 is 5. Subtract, you have 3. Quotient, remainder, dividend. So 8/5 is 1 and 3/5. 1 plus 3/5. So we have x to the 8/5 is x to the 1 plus 3/5. X to the first power, x to the 3/5 power. X, the 5th root of x cubed. And you're done. Okay. 5/2 now. 2 goes into 5 twice. 2 times 2 is 4. Subtract, you have 1. Quotient, remainder, dividend. 5/2 is 2 and 1/2 because we're writing it as a mixed number. And by definition, that is 2 plus 1/2. That's the whole portion plus the fractional portion. Okay. X to the 5/2 is really x to the 2 plus 1/2. 5/2, 2 plus 1/2 becomes x squared times x to the 1/2. X squared, square root of x. And you are done. And here you may notice you have a negative power here. So this is negative 7/3. Now, remember from beginning algebra and even intermediate algebra, any variable, any exponential with a negative power is written as 1 over x to the nth power. So this is going to be 1 over x to the 7/3 power here. Now, you still need to simplify down here that radical. So you go through the same process. 3 goes into 7 twice. 2 times 3 is 6. Subtract, you have a remainder. Quotient, remainder, divisor. 7/3 is 2 and 1/3, which is 2 plus 1/3. So x to the 7/3 is x to the 2 plus 1/3. X squared, x to the 1/3, it is x squared, cube root of x. Now that's not the final answer. So remember, this is the simplified radical. That's in the denominator position. So your final answer is going to be 1 over x squared cube root of x. Here you go. Okay, another negative power as z to the negative 4/3. So 1 over z to the positive 4/3. We still have to simplify down here. So we're going to take the 3 and it's going to go into 4. Goes in once. 1 times 3 is 3. Subtract, you have 1. Quotient, remainder, divisor. 4/3 is 1 and 1/3. Quotient, remainder, divisor. And that's 1 plus 1/3. Okay, remember this is what's really happening. So that now means z to the 4/3 is z to the first power plus 1/3. Okay, so we wrote it as a mixed number, and now this is z to the first power times z to the 1/3, which is z times the cube root of z. Okay, we're not done though. That's in the denominator position. So your final answer is going to be 1 over z cube root of z. You are done. Now, this is the next situation that I want to cover, algebraically speaking, that students come and they don't realize, and I think I didn't even realize originally myself when I first took calculus, that we can factor out the greatest common factor for these kind of questions here. So I'm going to do the odds again and leave the evens for you. Hopefully you follow this procedure. Now, greatest common factor, when you factor out an expression here. So let me make this a bit bigger so maybe you can see it if I can. All right. Here's the expression. It's a sum. That expression can be written as the greatest common factor times a quotient. Okay, so this is what it really means to factor out a greatest common factor. To write a sum or difference as the greatest common factor of the terms 2x and 6x to the 1/2 power. But then that's going to be multiplied by some quotient. And when you write that sum as the greatest common factor of the terms times a quotient, this is factoring out the greatest common factor. Okay. Now, what that means is you need the greatest common factor now. And you want to start with the greatest common factor of the numbers first, 2 and 6. The greatest common factor of 2 and 6 is 2. If you need to review that, please do. Now, we need now the greatest common factor of the variables, x, and there's only one variable, x to the first and x to the 1/2. So I'm going to do some algebra in purple. And I'm going to remind people that the greatest common factor of a variable with 2 powers, if you remember from beginning algebra, that greatest common factor is always x to the smallest of the two, smallest of n and m. Okay? So it's the smallest power. So what I'm really saying here now is, as you focus on the x to the first and the x to the 1/2, you have to tell me, or you have to know, what number is smaller. Okay, the GCF now of x to the first power and x to the 1/2 power is x to the smaller of the power. 1/2 is smaller than 1. Okay, 1/2 is smaller than 1. And so you're done. You found the greatest common factor. And so you're almost there. The second thing you have to do algebraically now is answer what the quotient is. So 2x to the 1/2 goes here. We know that's the greatest common factor. Now the question now becomes, what in the world is the quotient here? So let me show you how you can find this quotient here. Okay, what Q is. The quotient, you have to go back to what the expression was, what the sum or difference is. It is 2x plus 6x to the 1/2. A quotient is found by dividing. So what you do is you take the original sum or difference and you always divide by the greatest common factor of the terms. And we just found the greatest common factor. Right? The greatest common factor of these terms was 2x to the 1/2. So you have to find that GCF first. But you always divide by to get the quotient. The quotient is division. And so now you say, I get 2x over 2x to the 1/2 plus 6x to the 1/2 over 2x to the 1/2. Because you have a sum, so you're dividing both terms by the greatest common factor. All right, we're almost there. This is getting the quotient. So what you do now is you simplify your fractions. 2's cancel. This is x to the first power. So by properties, x to the first power minus the 1/2 power, because if you remember that algebraic property, properties of exponents, same base, different exponents, you're dividing, you subtract the powers, the exponents, you keep the base. 2 goes into 6 3 times, so this would be plus 3. And then x to the 1/2, x to the 1/2 goes away. They cancel. So this quotient is going to become x to the minus 1/2 plus 3. So here's going to be my quotient, ladies and gentlemen. This is that Q that we are looking for. Okay, so here's that quotient now. So what I'm going to do now is I'm going to bring this down here. Okay, let me write this here for you. Two x plus 6x to the 1/2 is equal to 2x to the 1/2 times x to the minus 1/2 plus 3. Now, in some sense, you're done. Because you have here, again, the greatest common factor. And then over here, you have a quotient. So now we can say 2x to the 1/2 you have 1 over x to the 1/2 plus 3. And so if we're just going to factor, I want people to kind of understand something here. Very often you see your answers as radicals. You can factor this. This is a factored version. So you can leave this answer this way to some degree. However, if you're going to use this in some way, algebraically speaking, you do have to do some arithmetic here. You do have to add this portion to simplify further. And how we can add right over here is going to be to have like denominators, right? This has the square root of x. So you're going to multiply here, square root of x, same thing. I want to do it in red. Square root of x over the square root of x. So that now we have the same denominator. So you get 1 over the square root of x plus 3 square root of x over square root of x, which is 1, 3 square root of x over that square root of x. So ladies and gentlemen, you get 2 square root of x, 1 plus 3 square root of x over the square root of x. Square root of x cancels. 2, 1 plus 3 square root of x. And we might have made a mistake. Let's see where the mistake is. Here's the mistake. Apologize. Let's go back. Our mistake's right in here. First example, we make a mistake in the arithmetic. Yep, we made a mistake. Here's the mistake. We're actually done. So I should have known that there. Okay. 1 minus 1/2 is positive 1/2. So 2x to the 1/2 will be x to the 1/2 plus 3. And you're done. 2 square root of x, square root of x plus 3. There you go, ladies and gentlemen. I knew something was wrong there, but there it is. Should have drank that coffee this morning. Trying to quit. So 1 minus 1/2. Here was the error. Okay. It's a very simple process, though, but this is what you'll see in your future, so I apologize with that one. So here we go, 15. Not going to record everything. We're just going to keep it like it is. Okay, ladies and gentlemen, there you go. And by the way, it's not a mistake if you find it yourself. So this is what we'll be doing in the future. We're going to do the same process here again. Okay? This is the expression. We need the greatest common factor now. So remember, the GCF will be greatest common factor of the terms. We need the GCF of 1 and 5, the numbers, and that's 1. And then the GCF of the variable, x to the smallest power. So I have to know what is smaller for the powers, 1 or 2/3. What is smaller is 2/3. So the GCF, ladies and gentlemen, is x to the 2/3 power. There it is. There's your GCF. There you go. Okay, remember, we're going to write this as the product of the greatest common factor and that quotient there. So at this point, we need a quotient. So you take the original difference now. That original difference is x minus 5x to the 2/3 power. We're going to divide by x to the 2/3 power. You always divide by the greatest common factor when you look for that quotient. You divide by that GCF. So we're going to divide by the difference. X over x to the 2/3 minus, let's not forget, 5x to the 2/3 over x to the 2/3. This is x to the first power. Okay. All right, now let's try not to make another mistake here. 1 minus 2/3 minus 5, and you notice that these terms go away. And this is going to be x to the 3/3 minus 2/3. See, that's probably why I made the mistake. I skipped a step. Now that's x to the 1/3. 3/3 minus 2/3, let's double check. And this is my quotient. Yes. All right. X to the 1/3 minus 5. So, x to the 1/3 minus 5. So remember, this is written as the greatest common factor times the quotient. The GCF was x to the 2/3. X to the 2/3, the quotient is x to the 1/3 minus 5. So you need the GCF. We need that quotient. And it's always a good idea to write this as a simplified radical. And it will be, okay, cube root x squared, cube root of x minus 5. And you factored out the greatest common factor. All right, here we go. Number 19. Okay. We're getting better and better with this. Greatest common factor, the GCF of 5 and 10. Do the numbers separate from the letters. Now notice the power. We need the smallest power there. We're comparing for the variable x, 1 and negative 1/2. The smallest power here is going to be negative 1/2. So I now have the GCF. So it's always the variable to the smallest power. 1 versus negative 1/2, negative 1/2 is smaller. Okay, the quotient again will be that 5x to the first plus 10x to the minus 1/2. It's always the original expression. Okay. Divided by the GCF. 5x to the minus 1/2. This is that GCF we just found. GCF, we put in red. There we go. So the quotient is found by doing the division, because that's what a quotient is. It's a division. But as you guys can see, we have to be careful here. 5 over 5, well, that's gone. And then this is x to the 1 minus a negative 1/2. There we go. Okay. Plus, 5 goes into 10 twice, and we cancel the x to the minus 1/2. So this gives you now x to the 1 plus 1/2. I'll write the extra step. And that'll be 3/2. Okay. This is that quotient we need. And so remember, GCF times quotient. I think we did purple for the quotient. And we did red for the GCF. There we go. 5x to the minus 1/2. times x to the 3 halves plus 2. Okay, now you factored it. But if you look in back of the book, because you wrote this as the GCF times the quotient, you're going to see 5 x to the 1 half. This needs to be simplified. We talked about simplification earlier. So x to the 1 half plus 2. Double check. Okay. So you'll have 5x square root of x plus 2 over the square root of x. Now leave this algebra here. This is the most useful simplified form you'll see in the future. But everything is accounted for. This is how you want to write these problems here. So I want to do a little bit of this algebra here for you guys because we'll see it in our future. Let me right here simplify. All right. Let's try 19 here. Let's go with what we're doing. Greatest common factor of 9 and 3. It is 3. And then you compare x to the smallest power. What's smaller, 1 or negative 3? Right? You compare the powers. Negative 1/3 is the smallest power. So you have your GCF. We just need the quotient now. 9x to the first, 3x to the minus 1/3 over 3x to the minus 1/3. 9x to the first, 3x to the minus 1/3, 3x to the minus 1/3 over 3x to the minus 1/3. So we're going to be careful. 9 goes into 3 times. X to the 1 minus a negative 1/3 plus your 3's cancel, and so does your x to the minus 1/3, and that's just a 1. So our quotient becomes 3x to the 1 plus 1/3 plus 1, or simply 3x to the 4/3 plus 1. Now remember why 4/3, because this is 3/3. This here is the quotient. All right. In purple. So remember, when you factor out the greatest common factor, it's the GCF times the quotient. The GCF was 3x to the minus 1/3. And then that quotient will be 3x to the 4/3 plus 1. Okay, so double check. And then we're going to do the same kind of simplification that we did. 3 over x to the positive 1/3. And then this will be 3x times x to the 1/3 plus 1. So be careful here, and that's x to the first, right? Because what we did was we simplified this radical in the way I described earlier. So this is 3 cube root of x, 3x cube root of x plus 1. Now, I didn't go through the detail for the last one, but I will now. You're really multiplying a fraction with a whole number. Remember that kind of thing. And you multiply straight across. So your answer is going to be 3x cube root of x plus 1, everything over cube root of x. You're done. And there it is. So this is going to be very useful for us in our future. All right, number 23. How many do we have to go? 23, 25. Two more to go. All right, we'll leave the evens for you guys. Here we go. Factor out the greatest common factor. Greatest common factor of the numbers 4 and 9. Okay. GCF of 4 and 9 is 1, by the way. And then now x to the first power, right? GCF of x to the minus 3 halves and x to the 1. That's going to be x to the minus 3 halves power. Okay, so we have the GCF. Pretty simple. The quotient. Take the original sum, 4x to the minus 3 halves plus 9x to the first power over really x to the minus 3 halves power. 4x to the minus 3 halves over x to the minus 3 halves plus 9x to the first over x to the minus 3 halves. Take out the numbers and the expressions here. 1 plus 9x to the 1 minus a minus 3 halves. Okay? Using properties of exponents over there. 1 plus 9x to the 1 plus 3 halves. Now 1 plus 3 halves, remember this, 2 halves. 1 plus 9x to the 5 halves. This here is your quotient. So the final answer, greatest common factor times the quotient. So we need that GCF here. GCF is 1x to the minus 3 halves. So here it is. 1x to the minus 3 halves is just x to the minus 3 halves. 1 plus 9x to the 5 halves. So now we do our simplification again. 1 over x to the 3 halves times the whole number of 1 plus 9 x squared x to the 1 half. Remember, you have to simplify that radical in the way we talked about earlier. That's why this technique was such a good thing to start with earlier with the first set. Okay, so we're going to see this in our future. Now, remember, we're multiplying two fractions now. So you're going to see now in back of the book, square root, not quite. There's a radical here we get to simplify, and that's going to be x to the first, x to the 1 half. So as a final answer, that's x square root of x. So here we go, ladies and gentlemen. We're going all the way to simplify here. Okay, here's the last one. GCF of 6 and 4 is 6. You do the numbers separate from the letters. And then x to the smallest power, comparing the power 2 with a negative 3. Well, that's going to be negative 3. So the quotient's now going to be 6x squared plus 24x to the minus 3 power over the GCF of 6x to the minus 3. So here's the quotient. Okay, here's that GCF. And here's the original expression. Okay. Six x squared, 6x to the minus 3 plus 24. Hold on. X to the minus 3 over 6x to the minus 3. Okay. Gone. X to the 2 minus a negative 3 plus 6 goes into 24 4 times. X to the, it's gone. Cancellation. All right. X to the 2 plus 3 plus 4, which means x to the 5th power plus 4. So here's our quotient. Okay, there's the quotient. And then we have our GCF. All right, final answer. GCF times the quotient. GCF, 6x to the minus 3 power. Quotient, x to the 5th power plus 4. Final answer, ladies and gentlemen, you're going to see in back of the book. 6, x to the 5th power plus 4, everything over x cubed. And you are done. So here's a nice way to get started to do some nice factoring for your calculus course, some nice algebra for your calculus course. These are the kind of things that you're going to find useful in your future. So I'm going to send them to you guys now so you guys can get started on this anyway. Have a great day. Take care and stay safe.